So I wanted to give a little bit background about myself. I am a mechanic. Hello. There is a little bit of echo, I think. Hello. Okay. Now it's better. Yeah. Uh, okay. So I just wanted to give a little bit of background about myself. I graduated in 2017 with a degree in mechanical engineering, and I worked as a sales support engineer at a company called Alfa Laval India. Uh, at this particular point in time, I had no idea about data science or artificial intelligence and everything. And the field had just started getting uh, popularized in India around this time. Then what happened is I had a natural inclination towards statistics and machine learn statistics basically. So I came to know about a course which similar to the one that this course is, which teaches the basics of data science and machine learning. And I took that course. I learned a lot about data pre-processing, data mining, data engineering, and obviously data science. And then I started my first job as a data scientist, as a remote data scientist at Ocular, which was a remote opportunity. This was during the period of COVID, post which here I was working on doing image based work, that is using convolutional neural networks and stuff to extract attributes from images, suggesting images to customers based on uploading whatever image of the product they have, so on and so forth. Post which I worked as a senior data scientist at Perfios Software Solutions. In this company, I was responsible for developing these face recognition systems that we commonly see in many different applications nowadays, especially in the KYC industry, or KYC, know your customer journeys that most of the banks have to do. And finally, right now I'm working as a senior associate at JP Morgan, where I'm working on the development of chatbots. So I have a overall experience of around 5 years in this industry, data science and artificial intelligence. And I would like to give you a bird's eye view of what it is like and how the industry has evolved and so on and so forth. So this is the agenda for today. First, I'll quickly give you a brief about what data science is, why data science, and then I will move to telling you about what is the scope of data science in India, followed by which there will be a use case. Now, the use case I would cursorily show because of the shortage of time that we have, but eventually you will be getting this uh, entire use case in the form of Jupyter notebooks. I will be sharing it to Naveen. He will be sharing it with you. And finally, we will have some time for the Q&As that you might have. Cool. So let us talk about some terminologies. So there is this thing called artificial intelligence, which is the blanket term or the umbrella term, which is used in order to specify or tell what is it that the entire, like, it is basically building of systems, and these systems are not manual in nature, these are automated in nature, and there are like these are supposed to do human help humans do some tasks. Now, all the rule based systems, all the database systems, all these things come under this blanket term of artificial intelligence. Then there is a specific thing called machine learning. So I will come up with a proper example in the subsequent slides. But what machine learning enables us to do is we can record a lot of data about any process or any what should I call anything in general. Now take the help of that data, define an objective, that you want to optimize for, and then let the system or the machine learn the rules that are needed to make predictions about whatever it is that you want. This is what machine learning is, and it is a subset of artificial intelligence because it is ultimately building systems which are useful for attaining some human goal or some human objective. But artificial intelligence may or may not use data. Artificial intelligence might just use human heuristics in order to mock that system or develop that system. Within machine learning now, there is something called as deep learning. Also, one thing I wanted to mention, I forgot to mention at the beginning of the lecture. If you have any doubts, please note them down as I go around. And then whenever we reach to the Q&A session, you can point me and you can ask me whatever questions you have. So yeah, going forward about deep learning. So deep learning is again a subset of the machine learning field where the the way in which we optimize these systems or learn these rules and all these things is by mimicking the way in which our brains behave. The way our brains behave is there are neurons and synapses and a lot of other things. We took inspiration, humans took inspiration from how the brains work and developed a system which is able to mimic that and then come up with like prediction rules and stuff which are able to uh, attain a said objective. So that is deep learning. Machine learning does not necessarily limit itself to just mimicking the human brain. There are many other algorithms in machine learning. That is why it is a broader concept. So deep learning is completely neural network based, and machine learning can include non-neural network based methods also, like logistic regression, decision trees, random forests, and stuff. You might learn more about these things when you would go deeper into the course. But right now, we will limit ourselves to understanding that deep learning is primarily related to mocking the human brain in order to attain a certain objective. Now, where does data science come in? Data science is a field which is overlapping across all these three, but there are certain things in data science which are away from, like, which are additional to whatever is mentioned over here, which is why you see in the Venn diagram that data science is having an overlap with this, but it is not completely contained within artificial intelligence or machine learning or deep learning, because data science is actually the science of dealing with data. All these things, artificial intelligence, machine learning, and deep learning, they have an objective in mind and they want to build a system to predict that objective. Data science, on the other hand, also has these aspects, but it has other aspects like analyzing the data, understanding patterns in the data, clustering the data, building pipelines which can allow us to seamlessly get the data from different sources and feed them in a way that the machine understands, so on and so forth. Like, data science is, in addition to all this, there are many other things. So I just wanted to give you a broad understanding of all the different concepts and where they fit in the Venn diagram. Cool. Now I wanted to talk about this paradigm of programming versus machine learning. When I say machine learning, I am including all these AI, ML, and deep learning within it. Uh, so on the left, you can see that we can have input data, predefined set of rules, a program, and finally an output. Let's say let's take a classic example of a calculator. So in a calculator, you know that whenever you enter 2 plus 2, you are going to output 4. This program is a very stable program and a handwritten program. Uh, there is nothing variable about it, and there is nothing to learn over here. It is a human rule that we have come up with, like the based on the rules of mathematics and stuff, that we are doing this. Or when you say in a computer program, if uh, time of the day equal to morning, print good morning. If time of the day else, else if time of the day is afternoon, print good afternoon, else print good evening. So this is a very deterministic flow of things, and it is basically telling you that whenever there is some input and there are some rules, you run a predefined set of rules and you get the output. On the other hand, like this is a system which is deterministic in nature, and it is programmatically enforced. Now what happens is this also can count under artificial intelligence, because as a blanket rule, as I mentioned earlier in the previous slide, artificial intelligence is something which is just a system which assists human to attain certain tasks. Now 2 plus 2 equal to 4 is also a task which humans want to do. So it comes under artificial intelligence's purview. However, when we have a task like detect a given a credit card transaction, if there is a fraud, if this transaction is a fraud, or given a uh, set of conditions in a cricket match, predict whether this particular team would win or that particular team would win after the first innings has happened, so on and so forth. So in these cases, what happens is there is no there are no heuristics or rules which are as deterministic as 2 plus 2 equal to 4. There may be experts who can make certain predictions based on, let's say, time of the day, the pitch condition, the nature of the ball used, so on and so forth. But there is different people have different analyses and different heuristics. So what machine learning does is it tries to study a lot of the past matches that have happened based on the data, who were the players in the match, uh, who were the what you can call it key impact players, who were who which team played away from their home ground, or which team played in their home ground, so on and so forth. All these things are called features, and it can crunch the numbers in such a way that finally it predicts which team won. And based on an optimization algorithm, it can finally come up with a decent amount of accuracy for computing, given a set of features, who would win or who would lose, or given a set of features, whether the credit card transaction that you are seeing is a fraud or it is a genuine transaction. So this is the machine learning flow. So you see how the thing has changed over here. You pass the input data and the desired output, and you get the prediction. Now ultimately what happens is the program part over here in programming is actually the machine learning algorithm over here, or the final machine learning model, sorry, the learned model over here. Now this learned model contains all the rules and all the heuristics which a human would have to sit and write and uh, manually curate in order to come up with a meaningful prediction. So given a set of data, if you have enough data, then you can define an objective function and create a model which can get it that ability to give you a prediction. So this particular paradigm is shifting over here. Here humans are writing the program in order to follow a certain patterns. Here the machine is learning the program in order to give the final output. Both of them are giving the output for a particular task, but over here humans have to write this